The most common isotope of hydrogen contains 1 proton and 1 electron. This is question 3 from the Coulomb's law problem set. Here's how to use Coulomb's law. I've drawn a picture at the bottom of the page to illustrate the setup. I have 1 proton and 1 electron separated by some distance. Now, it turns out the masses are unimportant, but the radius between them does matter. So I'm going to name that as R. That's how far apart these two are. So these two will feel a mutual attraction towards each other, and that R will matter. Now let's document the charges on each of these objects. And where I'm working from in my head is Coulomb's law. I've got R already. K is a constant, so I need to figure out what Q1 and Q2 are. Q, the charge. I'm going to start with the red proton. The proton has a charge based on this number. Elementary unit of charge is the amount of charge on either a proton or an electron. The proton is positively charged. And the electron negatively. And now I'm ready for my calculation. I have the 3 numbers that I need. K was given, up here further on the page, K is a constant, 9 times 10 to the 9th. The units on this get really hairy and messy. I wouldn't recommend writing them. And as long as you work in base units, everything works out fine anyhow. Oh, I'm running out of room. When you do this, you get negative 9.2 times 10 to the negative 8. We're talking about a force. Force is measured in newtons. The negative sign indicates the direction of the force between them. And it is not especially important right now. So leave it or drop it. Not a big deal right now. That's how Coulomb's law works. Good luck practicing with Coulomb's law. You got a bunch of practice problems here.